Hello everyone. Here is a problem on buoyant force or force of buoyancy. So in this problem, a copper weight is placed on top of a 0.4 kilogram block of wood with a density of 0.6 times 10 to the power of 3 kilogram per cubic meter. So the density of wood also is given. The mass of the wood is also given. Floating in water as shown in the figure below, what is the mass of copper if the top of wood block is exactly at the water's surface? This means the whole block of wood is immersed in the water, yeah, and they are floating. So if we draw free body diagram here, so free body diagram, wood has an mg, so there is m wood g, this is the weight of wood block, and there is another weight which is mcug, that is the weight of copper block. Since they are floating, therefore they must be equal to the buoyant force, which is acting upward, buoyant force. Okay, so therefore we can write buoyant force is equal to m wood plus m copper times g, weight of both. And that buoyant force is caused by pressure, by the pressure of liquid, which is water here in this case, right? And so this is one equation that we can write based on free body diagram we draw. But on the other hand, according to Archimedes' principle, which says that the buoyant force, which is FB here, is equal to the weight of the liquid or the fluid which has been displaced by the object. So the buoyant force, from the other hand, is equal to the weight of the water displaced. So we say m water g, which has been displaced. Displaced by what? By the wood block. Okay? Right? So we have two equations and then we can set them equal and we can solve this problem. But still we need to find the mass of water, how much mass of water has been displaced. So we use the density formula. Density in general says mass per unit of volume. And for wood is the same, for water is the same, but different densities, different numbers. So the relationship is the same for any substances. So we say the force of buoyancy or buoyant force is the weight of the water displaced, which in order to find the weight we need the mass of water. So instead of writing mass of water, I will write density of water times volume of water displaced. This is the volume of water displaced, right? Times g, because this term is showing mass. This is mass. Mass times g, right? Okay. So, but what is the volume of water displaced? The volume of water displaced is exactly equal to the volume of wood block, because the wood block is immersed in this water, right? And how to calculate the volume of wood block? The volume of wood block is not given. Instead, the density and mass of the block is given, wood block, right? So therefore, I can write, instead of this volume, I can write mass of wood divided by the density of wood, right? So this is what I can write. Instead of the volume of wood block, I can write the mass of wood block divided by the density of wood. Therefore, we just substitute this volume of water by this term. And then in this equation, we can write the force of buoyancy, or the buoyant force is the density of water, which is 1000 kilogram per cubic meter, times the volume of water displaced, which is the mass of wood divided by the density of wood, raw wood, times G. Okay, so this is the equation that we could make from this problem. And now we can set this equation, let's say this equation B with equation A, which we wrote from free body diagram at the beginning, right? So we can set them equal, and therefore we can say the mass of, so this G will be cancelled from both sides of this equation. So let's cancel this G from both sides of the equation, and I can write force of buoyancy, rho water, the density of water, times the mass of wood divided by the density of wood, which is equal to the mass of wood plus the mass of copper. I cancel out G from both sides of this equation and I set them equal. And both are equal to buoyant force. Equation A and equation B. From now on, we just need to rearrange this equation and we can find the mass of copper. So from now on, we need to rearrange this equation and we can find the mass of copper. Therefore, the density of water times mass of wood divided by the density of wood, which is the volume of wood in fact, minus mass of wood is equal to mass of copper, right? And therefore we can get mass of copper is equal to mass of wood times density of water divided by density of wood minus 1, okay, which is equal to mass of wood here is 0.4 kilogram times the density of water is 1000 kilogram per cubic meter divided by the density of wood here is given, which is 0.6 times 10 to the power of 3. Again, kilogram per cubic meter minus 1. And then the answer will be equal to 0.26666 kilogram, which is the mass of copper. And the problem is solved already. Okay, thanks for watching this video. Please like and subscribe.